continue to look at vectors today, and the main thing we'll be looking at today is the angle between two vectors. And we'll also be looking at work. So to be able to use the angle between two vectors formula, we need to be able to deal with the dot product. And the dot product of u and v would be your first vector, dot product, your second vector. Basically, it boils down to taking u1 times v1 and adding what you get when you take u2 times v2. Or in layman's terms, I would say basically multiply your x's, multiply your y's, add them together is what it boils down to. So here we have a vector. Once again, vectors are bold and italicized in standard position because of the angle brackets. We have vectors u, v, and w. So first of all, we're asked to do the dot product of u and v. So you have to multiply your two x's, the 2 and the negative 1. Multiply your two y's, the 6 and the 5, and then add those together, and we get 28. 28 because it was hungry. Yes, that was a joke in a video. Okay, here we need to do the dot product of u after we add v and w together. So to add v and w together, remember you got to add your x's, add your y's, so we get u and v added together, and we have to do the dot product of u. So here, once again, we'd have to multiply our x's, gives us negative 8, multiply our y's of 36, and add those together. Negative 8 plus 36 is 28. Now, it just happens that both of these have the same dot product. Does not mean you'll always get 28, so don't assume that. So now let's look at the angle between two vectors. If you have two vectors, a and b, the angle between those two vectors you can figure out using this formula. The cosine of the angle between your two vectors is equal to your dot product divided by the product of the magnitude of a and the magnitude of b. This is the angle between two vectors formula. I would encourage you to know this formula. Now, we would say two vectors are parallel if they have a vector angle between them of 0 or pi, or 0 and 180. 0 means they would be parallel and going in the same direction. An angle of pi or 180 degrees would be parallel but going in opposite direction, like one going up and to the right and one going down and to the left. Vectors are orthogonal if the angle between them is 90 degrees. But the easiest way to see if they're orthogonal is if the dot product is 0. To help you understand why we really only have to look at if the dot product is 0, this is our angle between two vectors formula right here. Well, if the dot product is 0, that means a dot b is 0. Well, 0 divided by anything is 0. So then you got to just think, when is the cosine equal to 0? Well, that's at the top of the circle, pi over 2 or 90 degrees, or bottom of the circle, 3 pi over 2 or 270 degrees. So basically, if your dot product is 0, this whole right-hand side simplifies down to 0, and then when it's cosine equal to 0, that's at 90 degrees. So the easiest way to decide if two vectors are orthogonal is if their dot product is 0. Could you use your angle between two formulas or vectors? Yes, you could. So let's go ahead and find our angle between these two vectors. We know they're vectors because they're bolded and italicized. We do our dot product. We multiply our x's, get negative 2. We multiply our y's, get negative 15. We add them together, and we get this. We now have to do the magnitude of this one. So we go negative 2 squared plus 3 squared inside of our square root. If you wanted, you could draw this out as a triangle, 2 to the left, 3 up, and find your hypotenuse. But either way, you get the square root of 13. And then we do this one here. 1 squared plus negative 5 squared inside of our square root, so it'd be 1 plus 25, or the square root of 26. Now, I've seen way too many people just have this right side. And then they'll just type that in their calculator and think they're done. But you're looking for the angle between two vectors. Write down the whole formula. Write down cosine theta equals. If you do that, you'll probably remember at this point, oh, I got to get rid of that cosine, so I'd have to do the cosine inverse of both sides. Then I just have to type this in. If you have an older calculator that does not have the fraction feature, you'll have to put the whole top of your fraction in parentheses, and then hit divide and put the whole bottom in parentheses. When you type that in, we get the angle between our two vectors to be 157.62 degrees. On the green problem, once again, we have two vectors. We want to know, are they orthogonal? So it's either a yes or a no. Could we go ahead and do our angle between two vectors formula like we did up above? Yes, but remember, if they're orthogonal, all we have to do is check their dot product. We multiply the x's, we get -4. We multiply the y's, we get +4. -4 plus +4 is 0. Remember, if they're orthogonal, our dot product is 0. So we would say yes, they're orthogonal because our dot product is 0. If the dot product's not 0, you would say no, they're not orthogonal. Now, a variation of your angle between two vectors formula. Basically, if you take your angle between two vectors formula and multiply both sides by the magnitude of A, then you get your component of A along B, denoted as comp for component of subscript B with A. And that is this formula. There's a few things in this class that we officially have to cover and that are never assessed and never part of the homework. This happens to be one of them. So we've officially covered it, but you will not be assessed on it. Now, we also want to look at work. Work is what is done by a force in a certain direction. Well, force in your direction are vectors, so it's really just the dot product of those. Or another way to look at it is your force in that direction, so your force multiplied by your distance. It can be done either way. Now we'll come back to that in a bit, but we're going to go back to that piano that we were dealing with yesterday. When we were dealing with that piano, it was a 500-pound piano, but now we're on a 45-degree incline. We want to know what's the force to keep the ramp or the piano from rolling down the ramp. So we draw this out. We have our weight going straight down towards the center. It's 500. The red, once again, is perpendicular. That's the weight of the piano that's on the ramp. Our purple is parallel to the ramp. That's the weight of the piano to keep it from rolling down the ramp. We're at 45 degrees from the horizontal here, which means this is 45 degrees, which would make this 45 degrees. Because these two angles here have to add up to 100 or to 90. So we are looking for the purple. Well, that's an opposite, and we know our hypotenuse, so that's sine. Multiply both sides by 500. We know the sine of 45 is root 2 over 2, and we get our decimal approximation.